Welcome to the deep dive. Today we're looking at something pretty big in construction, robotic bricklaying on major projects.
Yeah, it's fascinating stuff. We've got this case study from Cognitive Market Research.
Exactly. And if you're listening wanting to, quickly get up to speed on major industry shifts without drowning in detail, this is for you. We're looking at a real shakeup.
Definitely. We're diving into how one big construction company faced some really persistent problems.
Like what specifically?
Well, things like ongoing labor shortages, which is a huge issue everywhere.
Yeah.
And then the natural inconsistencies you get with manual work,
Yeah.
plus rising costs.
Right. The usual suspects in construction, but maybe amplified now.
For sure, especially with demand so high and frankly fewer skilled people available.
Yeah.
It really hits timelines, affects profitability.
Okay. So this company didn't just accept it. They went for a high-tech solution. Autonomous bricklaying robots.
That's the core of it. The goal was pretty clear. Boost productivity, rely less on skilled masons for that specific task, and just make projects more predictable.
Makes sense. Let's unpack that a bit. What were the specific pain points that really pushed them to try robots? Seems like a big leap.
Well, the report really hammers home how tough it is meeting those really aggressive deadlines on large infrastructure jobs.
Always a challenge.
Always. And then there's the quality aspect. Even with the best masons, you get variations in manual bricklaying. It happens.
And those small variations add up, right? Leading to rework.
Exactly. Rework, material waste,
Yeah.
it all adds cost and delays. So yeah, those were the big drivers.
Okay, so consistency and speed. Their main goal then, using these robots, was getting much higher precision, cutting those operational costs, and hitting deadlines, but importantly with top-notch quality.
Precisely. And it wasn't just about plopping robots on site. They built this whole digital system around them.
Ah, okay, so integration was key.
Absolutely. What's really interesting is how they linked the robots directly to the building information modeling, the BIM data.
Right, the digital blueprints.
Exactly. And detailed digital plans. This connection basically lets the robots read and follow the architectural design with incredible accuracy.
So wait, it's not like someone is sitting there with a joystick for each brick?
No, not at all. It's driven by these complex digital models. The robots are programmed to follow the exact patterns laid out there.
Yeah, okay, that dramatically cuts down the chance for human error, I'd guess. Misalignment and things like that.
But it gets smarter. The system uses real-time data, too.
Real time. How so?
It synchronizes constantly, so the robots can actually adjust what they're doing based on, actual site conditions. Things might shift slightly, or materials might vary a tiny bit.
Wow, so it's adaptive. It's not just blindly following the plan.
Exactly. Adaptive construction, that's what they call it. It can react.
That's pretty sophisticated. And the case study mentioned AI playing a role in quality control. Tell me about that.
Yeah, this part's really cool. The robots have these AI-powered vision systems. They're constantly watching the work as it happens.
Watching themselves work.
Kind of, yeah. They check brick alignment, how much mortar is being applied, the overall structural integrity, moment by moment.
Okay, like an instant quality check.
But it's more than just a check. There are machine learning algorithms analyzing data from past projects.
Ah, so it learns.
Yes. It learns, constantly refining its own technique. Like, it figures out the best way to lay bricks based on everything it's done before. It optimizes.
So the robots aren't just doing the job, they're actively getting better at it over time.
That's the idea. And the outcome is you basically eliminate those little inconsistencies you get with manual work.
Which means a more uniform structure, more durable in the long run.
Exactly. Better uniformity, better durability. And because it's learning, it's not just finding errors, it's proactively figuring out the best way, potentially setting new standards.
That consistency is huge for structural integrity.
Okay, let's talk speed. Time is money, especially on these massive projects. How do robots stack up against people?
The difference is pretty stark. Humans need breaks. They work set hours. Robots, they can potentially run 24/7. 24/7, wow. With minimal downtime, I assume.
Yeah, just routine maintenance. And the report says they lay bricks about twice as fast as a human mason.
Twice the speed. Okay, that's a massive impact on schedules.
It really is. And that speed up just ripples through the whole project.
Yep.
It means hitting those tight deadlines becomes much more achievable.
Which avoids delay costs, liquidated damages, all that stuff.
Exactly. All those associated costs just shrink.
Yeah.
And something else, you could deploy these robots on several sites at once.
Ah, scaling up the advantage across the company's portfolio.
Right. Imagine managing multiple big projects. This could seriously optimize your overall timelines. That 40% reduction we'll talk about later. It could genuinely change how projects are financed, faster turnover for investors.
Okay, faster, more consistent. What about materials? Construction generates a lot of waste. Do the robots help there?
That's another big plus. With manual work, sometimes you get a bit too much mortar or bricks aren't placed perfectly, leading to waste.
Breakage or just inefficient use.
Yeah. The robotic system uses these super precise dispensers for mortar and sensors to allocate materials. It knows exactly how much is needed.
So very little guesswork involved.
Right. Only the necessary amount gets used for each brick. It really minimizes waste.
Which saves money on materials, obviously, but also has an environmental angle.
Absolutely. Less waste means better resource use, a smaller environmental footprint. That's becoming really important.
Definitely a key consideration now. Okay, but what about the people, the skilled workers? Automation always raises questions about jobs.
Yeah, it's a valid concern. But the case study suggests it's more of a shift, actually.
A shift how?
Well, the robots take over the really repetitive, physically demanding part, the actual laying of bricks. This frees up the skilled humans
Frees them up for what, though?
for more complex roles.
Mm-hmm.
Things like project management, detailed quality inspection, sort of overseeing the robots and applying their technical skills elsewhere on the project. Technical oversight becomes key.
So it's optimizing the workforce, not just replacing them, using skills differently.
That seems to be the outcome here. Overall workforce productivity goes up. And there's a big safety benefit too.
How so?
Well, you're reducing workers' exposure to some of the riskier parts of the job, like working way up high or constantly handling heavy bricks and mortar.
Right, less physical strain, fewer chances for accidents.
Exactly. The report actually mentions lower injury rates, which also means lower liability costs for the company. Win-win.
That safety aspect is huge. Okay, you mentioned data. They must have numbers to back this all up, right? Quantifiable results.
Oh yeah, they tracked it closely. They did comparative analysis projects with robots versus traditional methods.
Yeah.
They found a 40% reduction in overall project completion time on the projects using robotic bricklaying.
40% faster. That is significant. Was that across different types of projects?
Yes, the study looked at a mix, including residential and commercial buildings. Consistent results.
Okay, and the cost. These robots can't be cheap up front.
True, there's an initial investment, but the cost-benefit analysis showed that the savings piled up quickly.
Savings.
Less labor for that specific task, much less material waste, fewer errors needing rework. It all adds up. They actually achieved a full return on their investment within 2 years.
2 years ROI, that's pretty compelling financially.
Very. And after that, it's just ongoing savings, project after project.
Impressive. What about the quality claim? A 30% improvement in precision? How do they measure that? Sounds tricky to quantify.
They used independent third-party auditors. These auditors assessed the construction accuracy both before and after the robots were brought in.
Okay, so objective assessment.
Right. And that 30% jump in precision has real knock-on effects. It means stronger structures, basically.
How does better precision lead to stronger structures?
Better brick alignment, more consistent mortar joints. It reduces the potential for things like cracks or material fatigue developing over time, so potentially lower maintenance down the road, longer building lifespan.
So it's faster, cheaper in the long run, and results in a better, more durable building. That's quite the combination.
It really is.
So how did all this play out for the company, for their clients? What were the big wins?
Well, being able to deliver faster and more reliably really boosted their reputation. Clients like predictability.
Sure. Developers, investors,
Yeah,
they want projects on time.
exactly. Quicker returns for them. It basically made this company a preferred contractor, especially for those high-value, complex projects where delays hurt most.
You build trust by delivering consistently. Makes sense.
And the sustainability piece we touched on, that became a real advantage too.
How so? Green building is big now.
Right. Reduce waste, better resource use. It aligns perfectly with green building initiatives. That's attractive to a lot of clients, especially public sector or environmentally conscious developers.
So it's a selling point beyond just cost and speed. It gives them a competitive edge.
A huge one. The case study makes it clear they position themselves as industry innovators.
Leaders in adopting new tech.
Precisely. And that opened doors. New business opportunities like partnerships with government bodies or big private developers who want cutting-edge solutions.
So it helped them win bigger, better projects, expand.
Yes, securing higher value work, even moving into new markets. It wasn't just solving internal problems. It was a strategic move for growth.
It really does feel like more than just a new tool. It's changing their whole approach.
Exactly. This case study really shows the potential. Widespread adoption of this kind of automation and AI could genuinely transform how we build things. For listeners, seeing this happen in construction, well, it makes you wonder where else these changes are coming. It could disrupt traditional timelines and costs across real estate infrastructure.
Absolutely fascinating. Okay, let's just quickly recap the key takeaways here. Robotic bricklaying seems to be tackling major construction challenges head on.
Speed, precision, cost, waste, safety. It hits all those points.
Right. We saw that dramatic 40% reduction in project time, a really solid 30% improvement in quality and precision,
Leading to stronger, longer-lasting buildings.
and significant long-term cost savings, getting that ROI in just 2 years, plus the sustainability and worker safety benefits.
Yeah, that sums it up well. It addresses a lot of the big headaches in the industry.
It really does. And, it leaves you with a final thought, doesn't it? If automation and AI can make this kind of impact on construction, which feels so traditional in many ways,
Right.
what other established industries might be right on the edge of similar, really fundamental shifts? It really makes you think about the future of work, doesn't it? How technology could reshape things we take for granted.
That is a really powerful question to chew on. The potential impact definitely goes way beyond just laying bricks faster.
Indeed. Well, that's all the time we have for this deep dive. Thanks for joining us.